Hi, let's look at operating servo using Arduino. In this example, I will use a typical 180-degree servo. Looking at the pinout diagram, you have three cables. Starting from the left, we have a ground. In the middle, we have positive 5 volt, and on the right, we have PWM signal. The good thing about this connector is that it is a standard connector, so all the servos will have the identical pinout. Almost all the servos have the same 5 volt operating potential. They all operate using a PWM signal. If you have a 180-degree servo, changing the PWM will change the angle. If you have a 360-degree servo, changing the PWM will change the speed. Next, I will also look at electronic speed controllers. Now luckily, these electronic speed controllers have identical pinout diagram. Starting from the left, we have ground, positive 5 volt and PWM signal. They also have a standard connector, but now they differ as they don't need a 5 volt operating potential. They actually provide 5 volt power supply for the Arduino board. They also operate on a PWM signal, and changing the PWM would actually change the speed. Therefore, to run a server, you'll need a PWM signal. First thing I'm going to do is start by making a new project in Arduino IDE. At this point, I've got two options. I can start from the first principles and create a signal that way, or what I can use is something called a library. Libraries are little programs that people have already made to do a certain task, and if you can find the library to do what you want, it's far easier to use them than to start from first principles. In the Arduino IDE, if you go up and click on the sketch button and then scroll down to include library, there you'll find a bunch of libraries pre-installed. If you want to install more, you can click on manage libraries and you can search for the library that you want. But for this example, I've already got the library that I want, and it's called Servo here. So if I click on that, it will automatically include the first line in the code. It's called include servo.h. This will make sure that when you compile, this library will also be compiled with your code. The next thing you need to do, you need to declare a servo. You do that by typing servo space, and then you can name the servo whatever you want. I'll just call it S1 for simplicity. Then what you have to do, you have to initialize the servo. The way you do that is you do s1.attach. Now here you can select which pin on the Arduino board you want the servo to be connected to. For no particular reason, I'm just going to choose the pin 7. And there are two commands you can use to set the servo position. The first one, you start by writing the name of the servo, which is s1.write. And in here, you put the angle that you want the servo to be. And the second command that you use is also starts very similarly. Start by writing the name of the servo.write. But this time, instead of using angle, you're going to use the microsecond value. So you write microsecond. And in here, you can put the microseconds value, and it will write that value to the server. The choice of the command completely depends on what kind of code you are running. If your code natively works in the angle values, then it's going to be easier to use the s1.write command, this first one here. If your code works with microseconds values, then it's a lot easier to use the microsecond command. This avoids having to use any conversion between angle and microseconds. Hence, you can save the calculation time and do something more productive that way. Now, if you are using the write command, you usually have a range of 0 to 180 degrees, which is a standard range a servo would have. And if you're using the microseconds command, you would have a range of 1000 to about 2000 microseconds. Now, these are not the fixed ranges. When you consider the microsecond command, it can vary, let's say 700 to 2300, or it completely depends on what kind of calibration that your servo has. So you need to be aware that these values can change slightly, and you need to calibrate your program for that. And as an example here, I've got the servo set to 20 degrees. If I change it now to, let's say, 90 degrees and upload the code to the Arduino, you can see the servo instantly changes in position. I can do the same thing by not using the write command, but using the microsecond command. Over here, I'll need to write, let's say, 1500, which is halfway between 1000 and 2000. That will also mean 90 degree, and the same code will operate the servo. And just to show you that actually works, let's say I set it to 1800, I upload the code, and the servo changes in position.